Hello once again. This is the third video to Module 2 of the Introduction to TypeScript course. Now we're going to cover a couple of various topics here: type inference, type assertion, using and creating interfaces, and type compatibility. Now, type inference in TypeScript is essentially the concept that TypeScript, when not provided with an explicit type, will go ahead and infer it from the different kinds of variables that you're going to be using. So, for instance, if you were to declare a string variable, TypeScript will go ahead and assume that the variable that you've declared is a string. Likewise, if you were to declare a number variable, it will go ahead and assume that what you have declared is a number. Now, the other method that TypeScript can use to determine whether or not, or what type it's supposed to infer for the variable that you're putting out there, is the most common type. And so this is especially relevant when you're dealing with arrays. So let's do an array of numbers. And let's say you've got the number 0, the number 1, and then you throw a null in there. Now, what TypeScript is going to do is it's going to basically look for the most common type among the array that you've got here. So if you hover over this, you'll notice that TypeScript has decided that this array is an array of numbers, which it is essentially correct, because that's basically what it's noticing is the most common type among the types that it sees in the values of the array. Now, type assertion is basically the concept of telling TypeScript, okay, I know what I'm talking about. This particular variable that I'm using is this particular type, and use it as such. Now, this is really useful from converting over from third-party libraries or converting over from using the any type. So that's what we're going to use in this particular example. So let's go ahead and declare undeclared type any, and we're going to give that a value of this is a string. Now, let's say that we wanted to use the length of that particular string. So we're going to go ahead and say let length of string. And we want to go ahead and tell TypeScript, okay, we're going to use this particular undeclared type variable as a string. So there are two ways that you can do this. The first one is to, and you're going to have to make sure that you put these in parentheses, by the way. That's one caveat that I noticed when I was doing this. The two methods that you can use to do this are to either use the as keyword. So in this case, we're going to do undeclared type as string dot length. And it'll go ahead and return the length of the string because you've gone ahead and told TypeScript, okay, this undeclared type variable is a string. And then the other method that you can do, instead of using the as keyword, is to enclose it in caret brackets. So string undeclared type dot length. And this will essentially have the same effect. Now, an interface is basically a descriptor of the kinds of types that you can expect in a more complicated object. So for instance, to create an interface, you can just go ahead and use the interface keyword. So we're going to name our interface square descriptor to basically create some parameters for a square. So we're going to basically give it a string for a name and a number for a size. So what this is essentially doing is creating a set of types that you can apply to different variables. So what this is particularly useful for is you can create methods to accept certain interfaces. So let's say we were going to create a square function. And we're going to go ahead and tell it that we want to only accept a square with the type of square descriptor. So we're going to tell it to return square.name. So this will essentially return the name of the square. Now this is kind of a useful purpose for using an interface, is because if you were to try to pass a different kind of object that maybe potentially didn't have the name property applied to it, this would go ahead and return an error. So an interface is a good way to enforce those parameters to make sure that the object that you're passing into the function has everything that it needs to do what the function is supposed to do. So then if we were to go ahead and create a square to match up to this particular descriptor, this is basically something that is going to meet the qualifications of a square descriptor interface. So this square has a name and it has a size. So we're going to go ahead and execute the function with our square variable. So note that this is all fine here, and we're not having any errors being thrown because this matches up the shape of the square descriptor like we mentioned. But let's go ahead and delete the size. And you can see that this no longer matches up. So it's letting you know right here that the property size is missing in the type, and that this no longer meets the shape that we've described in our square descriptor. So this function will no longer be able to accept that. And that's basically how you use that in a function. Another way that you can implement a interface is to use it in a class. So to do that, you need to use the implements keyword. And what that's basically telling TypeScript to do is to check the class to make sure that the shape of the members of the class matches up to the members described in the interface. So as you can see, if we hover over this right now, it's letting you know that it's not correctly implementing the interface. So in order to do that, we're going to need to define a name, and we're going to need to define a size. And they need to match the exact same type listed in the interface. Now, one more concept that I wanted to make sure that I ran through real quick is the concept of type compatibility. Now, when you're assigning new values to variables, TypeScript is going to check to make sure that the values type matches up with the variables type. So let's go ahead and make a new variable with the type square descriptor. And now let's make a new variable that doesn't match up at all to the square descriptor. So let's give it a size of a string and a name of 20, just totally backwards from what we were doing. Now, if we were to try to assign square 2 to false square, you'll notice the TypeScript throws an error at this. It would help if I spelled it right. Now, the TypeScript is throwing an error at this, letting you know that the two types of the properties are incompatible. So it runs through and it checks to make sure the types of each of these members of the object and make sure that the types are all compatible. And if it doesn't, it throws an error. So essentially the rule for type compatibility is every property of an object must match in type for it to be considered type compatible. If it isn't, then TypeScript will not allow you to assign that value to the variable that you are requesting. And that about wraps it up. In this video, you learned about type compatibility, type inferences, type assertions, and how to use interfaces to properly describe the shape of more complex objects that you're trying to use in your applications. I hope that this has been informative as usual, and hope that you will join us for the next video series in Module 3 of this Introduction to TypeScript course. Thank you very much.